Have you ever seen your clothes cling together on a winter day? Or maybe you've shocked yourself when you reached out to touch an object. If so, you've seen the effects of electric charges. This video explores electric charges and uses what you know about forces to understand how electric charges interact with each other. After completing this assignment, you should be able to indicate whether a given pair of charges attract or repel, indicate the directions of the force on a charge arising from other charges, and how this varies with the magnitude of the charges and the distance between them. Getting the most out of this video requires a solid understanding of how forces act on objects. Understanding electric charges and forces is important because electric forces underlie almost every interaction between objects in our daily lives, if we disregard gravity, of course. We also need to understand electric force to fully understand the movement of charges in circuits. Let's start off by considering two charged particles with which you are already familiar, the electron and the proton. You've heard the expression, opposites attract, and that is exactly what a proton and electron do to each other. We label the electron as having a negative charge on it, and the proton as having a positive charge. If instead we put two protons near each other, they would repel. Notice that in both of these cases, the forces act along the line that points from one charge to the other, and the forces become larger the closer together the charges are. Let's think for a moment about what would happen if there were more than one charge. Imagine that there are extra electrons on two dust particles, in addition to the many electrons that are already in their atoms. If there are two excess electrons on one particle, but only one excess electron on the other, how would the force between the dust particles be different, compared to the case in which there is just one excess electron on each? The answer is that the force is twice as large. Since each electron exerts a force on every other electron, and the electrons are stuck inside the dust particles, the total force on the particles is twice as large. We say that the force on each particle due to the other particle is proportional to the charge on each, Q sub 1 and Q sub 2. The force will drop off as the particles move apart, and increase as they move together. Putting these facts together, we find Coulomb's law, that the force between two charges is equal to the product of the charge on each divided by the distance between them squared. The constant of proportionality, K, simply depends on the units chosen for charge and distance. The units we use to measure the magnitude of the charge on an object are called coulombs. The charge on an electron is very small, negative 1.6 times 10 to the negative 19 coulombs. And we refer to the magnitude of the electron's charge as the fundamental unit of charge, E. It is worth noting that two objects will exert a force on each other if they have some non-zero net charge. All objects have charges in them since atoms are made of protons and electrons. However, it is possible to increase the charge to make it positive or decrease it to make it negative. For example, friction is sometimes enough to remove electrons from an object, making it have a positive charge. The charge gained by the cat must be equal to the charge lost by the balloon, a consequence of the law of conservation of charge. Just like any other force, the electrostatic force is a vector. Coulomb's law tells us the magnitude, but we also have to think about direction. If each cat has a positive charge, then they will repel each other. In which direction is the net force on cat number 1, if each cat has the same amount of charge on it and they are the same distance apart? The correct answer is upward. Note that the force of one cat on another isn't changed by adding the force of yet another cat. The forces simply add together as vectors through what is known as the principle of superposition. Now, if one of these cats had a different charge on it, the balance of forces would be different. The closer two cats are to each other, the larger the force between them is. Likewise, if one cat has less charge, the forces related to it will decrease, but the total force on any individual cat is still just the vector sum of the forces from the other cats. Let's review what we've learned. We set out to indicate whether a given pair of charges attract or repel, and indicate the directions of the force on a charge arising from other charges, and how this varies with the magnitude of the charges and the distance between them. We learned these through understanding Coulomb's law. which says that the force between charges is proportional to the excess charge on each object and inversely proportional to the square of the distance between them.